So good morning everyone. Welcome back to Power Electronics lecture 2 about semiconductor. Before I finish the remaining part, I'm going to review a little bit what I showed last week about the semiconductor and junction. I'm going to explain the functionality a little bit more because last week it wasn't very clear. Okay, let's say you have two semiconductor, p-type and n-type, and you join together. But initially, the form of charge of this one is 0. This one also 0. Okay. But due to the doping process that you mix between two different types of materials, so that the valence bond for the n-type is not complete, so there is one free electron, and for this one there is a missing valence bond. So the valence bond force attract electron from this side to this side. But because originally the form of charge is 0, but if some electron move from one side to another, then it forms certain of charge. So this one, the form of charge is negative. This one, the form of charge is positive. So then the attraction must be at the equilibrium such that the force coming from the valence bond and the force coming from the electric field must be the same. Okay, in equilibrium. And then when you have this junction and you apply voltage source to certain polarity, for example, in the first case, you connect negative polarity of battery to the P type, then the accumulation of negative side on here even more, and the positive charge form here even more. So the electric field grow higher. Then this electric field will be equivalent to the electromotive force from the battery. Then in this case, there's no current flow. So you have the diodes turn off. So yet actually this one is the form of a diode. The notation of diode is like this. Sorry, not notation, but schematic. So here it's called positive or anode, and this one is cathode. So if you connect battery like this, diode turn off. Okay. No current flow this way. No current flow this way. Okay. So it's turn off. And then you reverse the polarity of the battery, a positive polarity to the p type. Then you can have the the force from electric field stronger than force from valence bond, and this force is parallel with the electromotive force. Then you can have current flow. So in this case, the diode turn on. So you can see that this device is spontaneously turn on and off by itself. I mean, it just depends on the polarity of the source, right? No, we don't have a way to control it to turn on or turn off at some point, right? And for this one, this is a formation of a transistor, N-type. So you can see here is N. This one also N, and the middle is P. So this one is called NPN. And actually, for short, it's called N-type. It's a kind of monopolar. Yeah, I will explain later about this. But the function is like this. When you apply positive voltage through the gate, yeah, for the source, of course, this is only connect to ground, and this one connect to positive polarity of battery, for example. When you apply positive voltage through the gate, and because the oxide here is this oxide here is insulator, so it can only cause accumulation of positive charge in here, so that it attracts some electron from, yeah, for example, this one maybe have some impurity of electron or something, or maybe can attract some other electron from here to accumulate around here. Oh, sorry, electron. Then it forms the bridge electron from this end to this end, right? This N plus means just excessive of electron, okay, excessive electron. So it can allow the conductivity of electricity, okay, from here to here, and allow current to flow. In other case, you connect this gate by negative voltage compared to S. I mean, if potential here is lower than potential S, it means you connect G to negative polarity. Then you get the negative charge accumulate here, right? And then it repel all electron from this side to other place. So it accumulate all positive here, right? So in this case, it cannot form a bridge from this one to this one. Then this device turn off. Yeah, so this one is just another explanation, just like this one actually, but only show around the zone. So I don't need to explain here again. So here is the actual construction. This one is just like for simplify schematic of the structure of the MOSFET itself, but actually the construction is more like this. So you got like NPN is like this, and NPN like this, right? So current can flow from drain, yeah, when you put the right condition to turn it on. Current flow from drain to source through this, like this, and also like this. Because when p-type is inverted into n-type to bridge between this n and this n, or n this n and this n. So current can flows just like this. Okay. So this graph explains if you apply negative voltage on the gate here, and this is VGS, and then you increase the voltage to be on the positive side like this, okay, VGS. And what happened with the current and voltage down here? So you apply negative voltage through the gate, the device turn off, which means there's no current. So the blue represent current and the green represent voltage at drain and source. So drain and source, of course, connect to the batteries. If there's no current flowing, it means voltage is same as voltage of battery. Okay. So at this period or duration, the device is turned off and then start to turn on, but not fully turn on up here, right? So when it completely turned off like this, there's no current because the voltage applied through the GA is still negative, right? You put the wrong condition, I mean the condition that make it turn off. And when the voltage VGS start increase to positive part, then the device start to turn on. It means current start to flow, right? And until you increase the voltage more than the threshold that you can have it completely turn on. So completely turn on means you allow it to flow, the current to flow at the maximum that battery can supply, right? That's why you reach the saturation like this. So here you can see that in order to turn it on, to be completely on, you need the voltage at the GS to be high enough. So if you apply voltage that is not so high enough, for example around this region, you can see that the current can does not completely turn on. So at this region, it produces heat because it have a certain value of resistance, something like that. So like I said last week, we consider ideal case if the device function properly, you completely turn off and you completely turn on like this. Okay? Whether to let the current zero or let the current flow freely without resistance. I mean at the saturation that the source can supply. For this one, it's called IGBT, Insulated Gate Bipolar Transistor. The difference is just that here you have a mix between P-type and N-type. For MOSFET, you only have N-type, right? Here. And the IGBT has application with large current, actually. So it's not suitable for low power device with low current, because you can see that the P-type here, like you have combination N and P is kind of certain resistance. If you apply low voltage, low current, maybe it does not conduct at all. And so this one is called bipolar. Bipolar, because two types of charge flow, because you have P and N. So N means electron, excessive electron go to complete the hole and then it move out of the hole. So it's kind of like you can see if electron fill the hole and then it's out of the hole, so you can see also whole chain as well, right? So in some sense you can see the flow of the holes, something like that. That's why it's called bipolar. So two forms of charge flow in here. And again, if VGS is not high enough, then the current, you can see this curve represents low VGS, this curve representing high VGS. So high VGS means current can flow through from drain to source better, so current can be higher. So at higher current but lower voltage of VD. VGS. So again, in order to turn it on and off completely, you need to supply VGS high enough. Yeah, this one is diode, but the actual construction, not just like this one is just for a concept. So actual construction is like this, but still you can see junction between P and N. So if you supply, yeah, this graph explain the phase plane between voltage and current. You are supply negative voltage to diode. This is negative voltage. It cannot allow current to flow, but if you supply too high voltage, you break it. Okay, you break it means it does not function as diode anymore, but it just a normal conductor, or maybe you can burn it out, so it lost all the property as a diode, so it becomes just a conductor, normal conductor. You got it? Yeah. So the diode, we use it to have function like if negative voltage, it must turn off. If you supply positive voltage, it turn on. This is proper function of a diode. But it's burned out, it's broken, maybe it can conduct anyway, right? Both way, I mean. Another device called Transistor. This is Semicontrol. Semicontrol means you can program it to turn it on, to send signal to turn it on, but you cannot send signal to turn it off. It's going to be turned off by the circuit that force itself to turn off. That's why we call it a semi-control. And the symbol is like this, so you can see the schematic looks half like a diode and half like a transistor, because transistor has a gate. And here is a table to summarize schematic and some functionality of these components that I just explained. So the first one, diode, so it has schematic like this. The type of conducting current is bipolar, because you have P type and N type, and you form the bridge for it to conduct current from P to N. So bipolar. And type of control, we cannot control it. The circuit itself can force it to turn on or to turn off. Okay? We cannot program to send signal to turn it on or turn it off. So no control, like this, no. And current reversibility, we use diode as a device that block the current from one direction. It can only allow current flow in one direction. So of course, no reversibility of current. And voltage as well, no reversibility of voltage. Okay, so if you supply positive polarity of battery to here, current flow, so it means ideally there's no voltage across here, right? Because it's just a normal conductor, a zero, assumably zero resistance conductor. And if you supply like this, voltage, let's say here is 5 volts, and then if you, because this block current, it means the voltage is also 5 volt, right? Yeah. And this one is also diode, but it's kind of unipolar, so the construction must be different. from this one. So it's also diode, then the property must be the same as this one. I mean the function must be the same. And here is MOSFET. MOSFET is type of unipolar. Schematic is like this. This diode is actually to protect the MOSFET itself. It means if the potential from the source higher than that of the drain, then the current can flow this way freely, something like this, right? And if potential here is higher than from the drain higher than the source, then this one block the current, and the current will be controlled by G. Okay, we control through the gate G to allow the current to flow or not. Okay, because this is diode, right? So the type of control of this device is voltage. You need to have potential at gate higher than source. Okay, let's say if you this one connect to ground, which is zero voltage, zero potential, and here you connect to like 5 volts. Okay, then you can turn it on, but maybe 5 volt cannot completely turn it on. Maybe you need it up to 6 volt, 12 volts, right? So we can we can program to send signal to turn it on, turn it off, and can allow reverse current, but cannot allow reverse voltage. Why cannot reverse voltage? Because you have a diode here. If potential is higher than here, then current just flow freely. So there's no voltage across these terminals. You have any question? No question? So are you clear with when it has voltage across terminal, when it's no voltage?
I don't feel with voltage reversibility at MOSFET. What does it mean for voltage reversibility?
Voltage, yeah. Let's say it can lower voltage reversibility. Let's say you use potential here is higher and here is lower. For example, you reverse the polarity of the battery like this, and this battery is 12 volts. If you don't have this diode that allow the current to flow this way freely, it means you block current, then the voltage here is same as here, 12 volts. So it have reverse voltage, right? But you have diode here, then the current can flow freely. So there's no pressure, no voltage. And the next component is transistor, bipolar transistor. This emitter connect to the ground, and this one connect to positive voltage. And you can send signal to control it via the base. Okay. So it functions much like MOSFET, but this one is just for small current. In some case, you need to construct some logical gate to send signal to the gate for MOSFET. In some case, because MOSFET has gate, and the gate just need small current, because the type of control it is voltage. As long as you have high enough voltage, Small current doesn't matter. But anyway, MOSFET does not have current through the gate because it's field FH, right? So, but in some case, you use this kind of extra circuit in order to have the right condition to control power, higher power component like FET or IGBT, right? So this one for high power, this one just low power for small electronics. MOSFET also for higher power, but this one not very high, it's medium, but IGBT for the highest power. And the last one is Transistor, which is a type of a Semicontrol, also a type of bipolar, and we can control it by current, the amount of current. Oh, I forgot to mention this one. This one, the type of control is current as well. The higher the current through the base, the higher the current that can flow from collector to emitter, something like this. And you can control it to turn on, can control it to turn off, and this functionality is just same as all kind of transistor. No, not for MOSFET, right? MOSFET current reversibility is okay because you have MOSFET diode here to protect it actually. Because MOSFET, if there's no protection and you put a reverse polarity, then it's going to be burned out. Okay. Again, for IGBT, the control type is voltage, same as MOSFET, and we can control to turn it on and to turn it off. No reversibility of current and voltage. For Transistor, the type of control is current. The highest current through the gate, the higher current can flow from anode to cathode. And we can send signal to control it to turn on, but we cannot turn it off. Any question? Yeah, try to get familiar with the schematic, with the symbol. No question? So then we can finish this lecture.